Okay, so now on to multi-region high availability. We do have some news in the group. We just did get another sponsor. If you got the email, the sponsors are what helped make this group possible. Besides OpenSpan, where we're at, Cloud Checker came on. We asked you to take a look at their link and their site, and we appreciate their support. My name's Adam. I'm part of the cloud team here at OpenSpan. If you'd like to find out more about me and or OpenSpan, either go to openspan.com or find me on LinkedIn. So, what's in your SLA? How would you react to this statement? At approximately 8:44 p.m., there was a cable fault in the high-voltage utility power distribution system. Two utility substations that feed the impacted availability zone went offline, causing the entire availability zone to fail over to generator power. All EC2 instances and EBS volumes successfully transferred to backup generator power. At 8:53 Pacific time, when the generators overheated and powered off because of a defective cooling fan. At this point, the EC2 instances and EBS volumes supported by this generator failed over to their secondary backup power, which is provided with a completely separated power distributed circuit, complete with additional generator capacity. Unfortunately, when the breakers in this particular backup power distribution circuit was incorrectly configured to open at too low a power threshold and open when the load transferred to this circuit. After this circuit breaker opened at 8:57 p.m., the affected instances and volumes were left without primary, backup, or secondary backup power. Those customers with affected instances or volumes that were running in a multi-availability zone configurations avoiding meaningful disruption to their applications. However, those affected who were only running in this availability zone had to wait until the power was restored to be fully functional. This was a statement put out by Amazon during one of these outage periods. Now you'll notice that there hasn't been a real big notable outage since 2013, but it has happened in the past. Let's talk about the initial steps to high availability. And they include auto-scaling, CloudWatch, and elastic load balancers. Take the initial step. So if you have a simple web structure, let's say you have a web app and a database on just one availability zone in US West 1A. You now have several single points of failure. Right here at your one web app and your one database. Because if either of those instances goes down, your web app is going to stop talking, or your data is going to become unavailable. To remove your initial single points of failure, your steps are going to be not necessarily in each of these orders, but to add ELB, and the ELB is outside of your, we're going to call this your VPC because you really don't spin up an EC2 Classic anymore, but the ELB is a highly available service with no single point of failure. You're then going to add auto-scale. The auto-scale is right in here so that the ELB can talk to the auto-scale group and say at any point in time you want at least one instance up based on AMI. You then can add DB replication so that you can have a master and slave setup, and then add CloudWatch so that you can have monitoring to be notified at least if one of your instances goes down. Because in your previous setup where you had no monitoring, you either have to rely on third-party monitoring or at least coming and looking at it at some point in time, or having a customer call and say, hey, I can't get to my website, or hey, my order's not going through. And that's a bad situation where usually the salespeople are real unhappy. So then your next step is actually to move to separate availability zones. So each availability zone is in a separate data center. And so if something were to happen into that data center, then you're actually shielded in what can happen. So we're going to keep our ELB at this point in time. We're going to keep our auto scale, but now we're going to auto scale and have a number of 2 instances. And we're going to have our health check of always going to the 2 instances. We're now going to have our replication and take our slave out of the first availability zone and put it into the second availability zone. And so that way, if there's a failover, we're going to fail over our database from one availability zone to the second, and we're still going to have the CloudWatch across. Now the next thing we're going to add is Route 53 for our DNS system. And Route 53 again is a highly available service. And so as the people come in from different areas, and if your DNS server were to go down, that wouldn't happen with Route 53 because it's using different edge locations which are located all around the world, and would then redirect your DNS traffic right to your ELB, and then we'll go to the first, to the right now you're doing route, it's doing simple round robin traffic to your web nodes, and if any of them were to go down, it would just simply direct that traffic to the node that was up until it auto-scaled the correct number of nodes up. Configuring your Elastic Load Balancer to use multi-availability zones. The load balancer can be configured to work with multi-availability zones. If you're using a VPC, make sure to add your appropriate subnet. So if you configure all this inside of VPC versus EC2 Classic, make sure each subnet is correctly configured inside the ELB. But what happens if your entire region is affected, like your entire US West 2 goes down and you're just in a state of blackout? Your answer is then to move to multi-region design. This then becomes a lot more complex, but it's still accomplishable. So, your Route 53 is still your your DNS service and has no single point of failure. Your Route 53 and ELB are still going to work hand in hand. You need to break your master and replica set out, because now we have this is region 1 of US West 1 and region 2, and now we still have our availability zones in each one. But instead of having master and replica, we've now moved to RDS, which can sync across the regions. Our web applications are now going to be set to sync to an S3 backup, and S3 backup is a highly available service that's just moving across edge locations. And the CloudWatch can monitor at all points in time for any failures in any one of the availability zones. So if a whole region went down, your Route 53 can go to your ELB and then redirect all traffic to the second zone. And with replication going through your S3 backup and syncing, and your database syncing through RDS, you would never have a single point of failure at any point in time. Looking at Amazon's global structure, you have 10 different regions that you can actually sync to from the east, and then you have 25 different availability zones being cut from those 10 regions, and then 51 edge locations. Those edge locations, and then here's a different look at it. So the edge locations are where your S3 buckets and your Route 51 DNS servers and actually CloudFront can be served from if you're using CDN. So what services use edge locations? CloudFront and then Route 53. So Route 53 and DNS failover. In February 2013, they introduced the feature integrating the DNS and failover, and then Route 53 can actually detect an outage in one region or in one location, and then redirect your users to an alternate or backup location. The failover for the ELB is available at no additional charge. So when you have more than one resource performing the same function, you can, for example, you can have one HTTP server or one mail server. Configure the Route 53 to check the health of your resources and respond to DS queries using health-only resources. So let's go back to our diagram for a second. So the Route 53 can actually be checking your different resources, and if it detects that one goes down, it can automatically redirect to the healthy resource, is what that's saying. And then you can set it up. There's 3 different ways to set it up, but it's mainly 2 different ways to set it up. So you can have an active failover, And you want to use that failover configuration if you want all of your resources to be available the majority of the time. And when a resource becomes unavailable, it can detect it's unhealthy and stop including it in responding to query. That's mainly meaning, so it's going to go and send out basically a ping, and as you're directing traffic to the node, if it detects it's unhealthy, it's going to go to its next target and try to respond to that. And the active passover failover is basically going to say you have a whole. This is basically the way set up in that architectural diagram. You want a primary group of resources to become available, but you have a whole separate group of resources on standby. So your primary zone is going to be your first short latency point that you're going to redirect your traffic to. If for some reason that becomes unavailable, the Route 53 is going to direct everything to your secondary setup when your primary resources become unavailable. This is how the routing happens with the Route 56 and the Route 53 and DNS failover. So if you did a query for example.com, it would go through and it would go through its weighted resource set, and it would go through, if the health check passed, if it failed, it would go over and then jump back up to its second target in the south and in the secondary region. Go through and its resource set again, and if it passed, it could then go through and successfully perform the request and return back, because this one's going to return 404, this one's going to return 200. The pros and cons of a multi-region high availability. It's a scalable and highly available architecture. And the event of failure to one region, the traffic can be diverted quickly in just not even seconds, but microseconds. It allows you to maintain your high time for your service level agreements, and customers aren't lost due to load or latency problems. The cons: it costs more than a regular multi-availability zone setup. It's somewhat technically complex to get set up and also maintain sometimes, because what happens if your database gets out of sync, if you try to do just databases by themselves and you're not using RDS, what happens if you can't use RDS because you have encryption requirements? It requires mid to advanced knowledge of more AWS services. It's not like you can just know EC2 Classic and EC2 and a little bit of S3 and then you're off and running. No, you have to know a lot more of the services. And then at this point in time, you pretty much had a complete dependency on Amazon Web Services. So you're not going to use a little bit of Amazon, a little bit of Google, a little bit of Azure to kind of get this. I mean, you are deciding you are committed to Amazon, and which is fine because they can do it. I mean, if you commit to something else, they might be able to do it. The building blocks of high availability. So the following services, when you're trying to actually construct your architecture: object and file storage, S3. S3 uses your edge locations. Content delivery, CloudFront. Once again, CloudFront will use those edge locations which are located all around the world. Load balancing, ELB, that is a highly available service. It's not like a single instance. Monitoring, CloudWatch. Once again, that's a highly available service. It's not dependent on one instance. And then messaging, SMS. So if something happens for the CloudWatch, and SQS as well as that. So if something happens, with the CloudWatch, it can actually send you a message, or it can send a notification to SQS to actually automatically spin up something else in its place, where you could actually be sleeping, and Amazon can automatically take care of it if you program it right. And that's it.
I think you almost answered my question on CloudWatch there. Question. So I want to use it where it can send you a message if something goes down. But how complex can you get to automate it to spin up other stuff or to continue on?
Yeah, you can. If you use it with auto scaling, you can actually have it, if you have a, let's go back to the diagram. So if you have your, we don't even need a multi-region diagram, we can just have the two availability zone diagram. So if we have the CloudWatch monitoring our autoscale group, and we're supposed to have 2 instances, 1 in each zone. And so this one goes down. Just from somebody terminates it, a developer terminates it by accident, it just goes end of life cycle and it goes out. And so if it's set to a specific AMI to come up like in a CloudFormation template, it'll automatically bring up a brand new AMI in this availability zone because it knows it has to be load balanced. And it'll send you an alert and say it's been terminated. And then if you have a secondary alert for and have 2 notification topics, it'll actually say alert down, and then when the next one comes up, it'll say recovery. And depending on how long of a notification time period you need, whether it be a minute or 5 minutes, the CloudWatch notification is one item, and then autoscale is a second item. That's what I'm saying, is it starts to get complex of each service needs its own, and then you could actually do it with CloudWatch and SQS, so that, because what happens if this instance isn't, your AMI isn't totally complete, it actually needs a little massaging sometimes, so you can actually send it to SQS that actually tells it to pull down things, that has a little script that runs, that has to go and grab something from a bucket and then kind of run a shell script. So that can be done a little bit with SQS, the simple queue service.
I've got a couple questions. Can you go to the slide with the example.com? Yeah, that. So in Route 53, how do you tell it to go to 2 different load balancers? You have 2 different ELDs. You have 2 different records in there. Does that sound right?
It is going to, you're going to have a name, you're going to have an alias, you're going to have an A record for an A name.
Right.
And then,
You just say,
yeah.
this one is basically like you can add multiple IPs to, whatever. You can just drop in the DNS name for each one of those A records.
right, and you're usually going to have an A record, a listing of your A records to point to, and then it's going to choose the point of least latency. So as it queries the different items on those A records,
That was my next question. I think I read something about latency-based routing or something like that.
Right.
Is that what you're talking about?
right, so it's going to keep Amazon's going to keep basically, I don't know if it's necessarily a table, but it's going to keep a record of, if I have an ELB, you really, when we go back to you really should have, if you're trying to do a multi-region design, you almost, what I've read from it is you should have one ELB that's kind of bouncing back and forth, and then if you need internal ELBs inside your architecture, that's another thing, but you almost want to have one going back and forth between both of them.
Okay.
And so that's why you're going to have the one going down, unless you're trying to do 2 on top and only have one to fail over to the other resource set. So you have the one on top, and it's going to go back and forth, and then you might have another 2 inside of here.
Well, I think you may have already said this, but I think there's 2 goals. One is to make, like, a user on the West Coast go to the West region, right?
Right.
And then another goal is, if the West region is down, then redirect to the...
I actually did these on both West Coast regions, because one was just for a pure backup in case, because my thinking was, this was US data, it didn't want to go outside of the United States zone. I didn't want it to travel outside the United States, or just for data purposes. Because sometimes you're going to have a customer like that. They're going to want to have, European data that doesn't want to travel outside of Europe, just for data protection purposes.
Is it only RDS for MySQL that offers the multi-region
I don't-
application today, or
No,
the other
they just announced it for SQL Server.
for SQL Server? Okay.
I think, I'm not
All
sure.
of them have it now.
Yeah, I was going to say, I think Postgres has it. as well, you'd have to check the availability in your region for which services, but as long as you can spin up an RDS in that region, you know, and you can spin it back and forth between the two regions, you should go to share and then sync across.
And it's still master slave, it's not
Yeah.
master, right? I use RDS, I don't know. if they-
Yeah, I haven't used RDS in 3 years. I could talk about Elasticache, but,
I think you're right.
I don't think it's master.
Yeah, I think it's master slave with low latency replication. So you're,
But do they replicate back to the other one, or if you hit the?
But you only see your rights to the master.
yeah, and it'll, I mean,
So if you hit the West Coast one, it reaches over to the East Coast to right to it?
You'd have to do
until
that with your
it
master.
flips over to become the master. Like if this one went down, this one would take over as the master, and then if that came back up, it would have to know that it became the slave again.
Okay.
And
Oh, so
then
it's
it's-
right from.
Whenever you do your right, you just use your master database handle.
Okay.
Because wherever it goes, it goes.
Because there's
Maybe
usually
a long trip around the world,
Yeah.
for the right.
there's usually a one endpoint, and you're not actually going to, when your application's hit it, it's going to one endpoint, and it's going to go to whichever one is the master at that point in time. And because you're either going to promote it up or promote it down, Amazon handles a lot of that versus where when you're running MySQL master slave or Postgres master slave, you have to control all that and then either have something on top like the Lua server where you have that one endpoint, or change the IP address back and forth. But that's handled a lot of ways by, they do that for RDS where they have that one endpoint and then you bring up the nodes underneath. Yeah. So I know they did it for Elasticache.
Exact same.
Yeah.
This is kind of new to me, but I'm trying to understand, why would I use Route 53 to fail over if I'm also using ELB? I thought that's kind of a redundant function. Or am I misunderstanding?
ELB won't help you across regions.
Yeah.
Oh, it doesn't, only availability zones within a region?
Right.
Okay.
And your Route 53 is, your Route 53 is, your ELBs are only in your regions, but your Route 53 is available on all the edge locations.
Okay.
It's almost like Route 53, like F5 GTM, global traffic managers, versus the LTM is for the EOB function.
Yeah, I just wasn't clear on ELB.
No, it's not expensive. I mean, it's per,
You
I think
only
per
provide the
hits.
IP, right?
Per million.
per
Only
million.
provide your IP, which
Yeah,
is
so
not
let's see
a lot,
on your
right?
5-round slash.
And you still need DNS with resolving and also.
I don't know if there is a free
I guess
service
intelligence
on
services.
Amazon. You get a free trial,
Pick versus simple run, of course.
but I don't know if there is anything that's actually free.
Right,
They get you hooked.
Yeah, I saw something free on the slide.
Oh, it's a free, you have,
There's no.
failover to ELB, no additional charge.
So
It's the add-ons.
yeah, if there are latency, etc.
It's worth every penny.
I got a question for the group. I'm curious.
F5 probably takes it.
Of everybody that's using auto scaling, are you doing it per auto scaling group per zone, or are you doing it one for the whole region?
I have so many, like, I have two different, I have like multiple products, and so it's tough, I think it's per region, per product.
We usually do per zone, and I
Yeah,
was
per-
curious, because like, I've had issues where we were trying to do the whole thing in like, we used East, we like did one auto scaling for all the East, and we said, use any of these 5 zones, and it just got to be, sometimes it would start stuff, and it would like, there'd be like 4 instances running in one and 0 in another, I'm like, what's the point, like, shouldn't it be spreading it out a little more?
No,
I'm using it
I have it per region.
across the whole region, and I haven't seen a problem.
So I just felt like I found that I could control it better, and be more consistent with it, like, I want these 4 zones, so put one in each 4 zones.
Yeah.
I have it in VPC though, so it knows it has to have so many in each availability zone per the subnets. All right, that's my presentation.